Okay guys, in this problem, it says we're given this big long equation, right? And it asks for the following, which it says find standard form, center, ABC, foci, and then the rest, right? Once it says foci, I know this is talking about an ellipse. So first off, this is not in the standard form. That's what it wants us to find. In order to do that, it looks like we're going to have to maybe complete the square here. So the first thing I want to do is kind of group my x terms together, my y terms together, my constants on the other side of the equal sign, complete the square, and get this in standard form. Let's try it. All right, so first off, my squared term, my x squared, we're going to write that first. And then the other term with an x, minus 96x. And then we'll leave a space because I'm going to have to complete the square. And I might even have to take out a 16 there. I think 16 is in common. We'll see in a minute. But let's just leave a space just in case. So we have plus 25y squared. That'd be the next value. Then my just y minus 200y equals negative 144. Okay, so we got our x's and y's together. Now, like I said before, I think 16 goes into 96. Let's just double check that. 96 divided by 16, yes, is 6. So what I can do is I can take out a 16, and that's going to leave me with x squared minus 6x. Again, I'm going to leave a space there because eventually I'm going to complete the square. Same thing on this side. I know 25 goes into both of those, so I'm going to take out a 25. Left over after I factor a 25 out is going to be y squared minus, and then 25 goes into negative 200, negative 8y times. Okay. Oops, I should leave a space. And then that equals negative 144. Okay, here's where this gets a bit interesting compared to when we did circles, for example. Because when I complete the square here, I'm going to take half of my b term, so divide negative 6 by 2, which is negative 3, and square it. Negative 3 squared, of course, is positive 9. So I'm going to add in 9, but what I'm really adding in is 16 times 9. Okay, 16 times 9, because there is a 16 out front of this. So if I go 16 times 9, I think is, yeah, it's 144. Over here, I'm going to have to add 144 to the side. I cannot just add 9, right, because 16 is being multiplied, so I have to add 144 instead. Likewise, in this one, half of my b term squared, so negative 8 divided by 2 is negative 4. Negative 4 squared is 16. I put the 16 in there, but really this is 25 times 16. So 25 times 16 is 400. So again, on this side I have to add 400. So what did that do? Well, over here, that leaves me with, and I'm kind of running out of room, but leaves me with 16 times my binomial squared, which would be x minus 3. All right. And then on this side, it'd be plus 25 times the binomial squared. For the y's, y minus 4. Okay. And on this side, let's see, negative 144 plus 144, those cancel, leaving me with just the 400 that we added over. So 400 like this. Still does not look like an ellipse. Ellipses are supposed to equal 1. So I need to now divide by 400. I'm going to divide by 400. And if I do it to one side of my equal sign, I have to do it to the other side. I can split it up, so I do it to both of those parts on the other side. That's fine. Divide like this, 400. And then what this is going to do is it's going to create a denominator on the bottom that, of course, is bigger than our numerator. And so one way to kind of think about this is almost like you do 400 divided by 16, and that's what's going to be left on the bottom side. Let's try that here. So again, I'm running out of space, but if I write just the tops in our binomial squared parts, plus y minus 4 squared, and I know this is going to equal 1 now. So like I said, if I do 400 divided by 16, it's kind of a trick to get our denominator. It's going to be 25. So on the bottom of this one, it's going to be 25. And then same thing over here. Well, we can almost figure it out, right? 400 divided by 25 should give us 16. Just to double check, 400 divided by 25, of course, is 16. So that's going to come down on the bottom. Now this is in standard form. Right there. So that's what I probably should write over here. X minus 3 quantities squared divided by 25 plus y minus 4 quantity squared over 16 equals 1. And I'm going to erase this just to give me some more room for these other questions we have to answer. And we'll go off of this part. So when I find the center now, we can answer the rest of these questions. When I find the center of this, now it's going to be 3 and 4 for x and y. 3, 4. I should also mention this is currently in standard form because the denominator of our x's is larger than the denominator of our y's. 25 is bigger than 16, so that would come first. All right, anyway, no matter which way it is, the center is still the xy term, 3, 4. Our a, b, and c is going to be the square root of our bottoms here, right? Because this is a squared and this is our b squared. So a would be 5, b, square root of 16 is 4. And then our c, the way we can figure this out is it's a squared minus b squared equals c squared. So in our case, 25 minus 16 should equal our c squared, and that ends up being 9 equals c squared. So c is going to be 3. Okay, this is, yeah, just a 3 there. So then our foci, again, if you kind of visualize this in your head here, the point 3, 4, since our x has the larger denominator, this is going to be longer than it is tall. Again, this probably isn't the best, but I'll say 3, 4 is in the middle, so we can kind of visualize this. Our foci are going to be left or right our c amount. Okay, in this case, c is 3. So if this is the point 3, 4, if I go back 3 spots to the left, that's going to be 0, 4. Okay, so one of my foci is 0, 4. If I go to the right from 3, 4, that would now be 6, 4. That's another foci. If I want to find the major axis vertices, those are, again, along our long way of the ellipse, whether it's like this way, there's kind of a short, fat one, or if it'd be a tall, skinny. In this case, though, like I said, short and fat. So if we go back in our major direction, that's 5 spots. Compared to 3, 4, this would now be at -2, 4. Let's see, that's for my major. So I know I'm getting rid of space, 2, -2, 4. And if I go to the right 5 spots, that would be 8, 4. Okay, what else is this one? And what's the major axis? Well, that point, these all are along the line y equals 4. So that's going to be our major axis, y equals 4. Our minor axis vertices would be perpendicular to our center this way. And along that line, it would be where it touches the ellipse. And remember, since our b was 16, b squared is 16, our b is 4, this is going to be 4 spots up and 4 spots down compared to 3, 4. Well, if I think about up and down compared to 3, 4, 3, 4 plus 4 would be 3, 8. And 3, 4 down 4 spots would be 3, 0. Okay, so those are my minor axis vertices. And then lastly, my minor axis, all of this is along the line x equals 3. Okay, x equals 3. So I think there we had it. We completed a square. We moved this over since this has to equal 1 on this side. And then that gave us our denominators, our a squared and our b squared, if you will, for our a, b's, and c's, our foci, major and minor axes, and our major and minor vertices of this ellipse.